Hello and welcome to Empowered Learning. This particular video will be on the basics of dealing with exponential expressions and exercising some of the exponential rules that we need to learn here. So we start off by noting that exponential numbers are numbers that we consider raised to a power. And so as an example, we know that 2 raised to the 4 means that 2 is being multiplied by itself a total of 4 times. So 2 is being multiplied by itself by a total of 4 times. In general, if we had some expression a raised to the x, that means that a is going to be multiplied by itself x number of times. And so a raised to the x is called an exponential expression. Okay? Now, if we had some real number n here, for example, 25, then if we said a raised to x equals n, if we had that situation, then we call this an exponential equation. And so the main reason I'm throwing this in here is that there is a difference in between an expression and an equation. The main thing is equations have equal signs in them. Expressions do not. Okay? So moving on here, some of the basic exponential rules that we will encounter will be the following. We know that anything raised to the 0 power is always equal to 1. Okay? We also know that anything raised to a negative power is the same thing as 1 divided by that same thing raised to a positive power. Anything raised to the sum of 2 powers can be rewritten as the base raised to the power of x times the base raised to the power of y. And so similarly, a raised to the x minus y will be a raised to the x divided by a raised to the y. So here we have some others. We have if we have the product of 2 things all raised to the same power, that means we could raise each of them to that same power and then multiply the answers. And same thing for the quotient of 2 things, or 2 expressions. If we have that raised to the power, then we can raise the numerator and denominator separately and then divide those answers. We also have another exponential rule, it's not written on here, that looks sort of like this, which says that if we have a raised to the power of m multiplied times itself n number of times, then we can just multiply the exponents together, and that will give us the result. So in short, for the exponential a raised to the x, we know that a is going to be called the base of the exponential expression. X is going to be called the exponent. And so a to the x is called in power or an exponential in general. And so that's one of the reasons why up here I called it an exponential. So now that we got some of the basic vocabulary and rules out of the way, what we want to do now is exercise how we're actually going to compute this exponential numbers or expressions here, okay? So we start off with easy stuff and we try to be a little bit more difficult as we go along. So we see our first example, 3 raised to the power of 4 is just 3 multiplied times itself 4 times. And of course we know that 3 times 3 is 9. So this is essentially 9 times 9, which is 81. Our next example, we see that we have negative 6 raised to the power of 3. So that means we have negative 6 times negative 6 times negative 6. Okay. Now, of course, we know that negative 6 times negative 6 is a positive 36. And if we do a positive 36 times a negative 6, then I believe, if I'm correct, this would be a negative 216. Okay. So in our next example, we see that if we have a negative 7 raised to the second power, or negative 7 squared, we need to think about this in this way. So here, according to order of operations, we need to first do the exponent, which is 7 squared, which is just 7 times 7, which ends up being 49. And then after that, we need to do the implied multiplication here. So multiplying 49 by a negative 1, which gives us a negative 49. Okay. For our next example, we see that we have D is 3 times 5, all that raised to the third power. So that means that we're taking 3 times 5, multiply times itself 3 times. And of course, 3 times 5 is just 15. So we just multiply 15 times itself 3 times, which ends up equaling 3,375. So in these next examples, we see that following order of operation, we have to do exponents before multiplication. So we do 5 cubed, which is just 5 times 5 times 5. And of course, 5 times 5 times 5 is 125. So 3 times 125 is 375. For example F, notice that this negative 4 cubed is not written like this. Okay. So since it's not written like this, we cannot assume that this is going to be negative 4 times negative 4 times negative 4. Okay. So what we see here and what this is not the same thing. Okay. So we want to make sure that we understand that. So getting rid of all this, we'll see that what we need to do first is do the exponent, and then afterwards go ahead and do the implied multiplication. So think like in an earlier example that we had, example C, we have to think of this way. And of course, 4 cubed is just 4 times 4 times 4, which is 64, and negative 1 times 64 is a negative 64. So moving on, we'll see that negative 2 raised to the 5th power is just negative 2 multiplied times itself 5 times. Of course, anytime we have two negatives multiplied times each other, that is a positive. So we end up with a negative answer. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And for H, we see that we have 2 times 4, all that raised to the 3rd power. Now, if we remember from one of our exponential rules, we have this, we could rewrite this as a raised to the n times b raised to the n. So here we could do 2 cubed times 4 cubed. 2 cubed is just 8 because that's 2 times 2 times 2, and 4 cubed is 64. Okay, so if we multiply 8 times 64, we should get 2 raised 3. That should be 512. Okay, and of course we see that if we don't put the 2 times 4 in parentheses and just leave it like this, we see how the answer drastically changes. Okay. All right, so let's go ahead and run through these examples here as well. So this is things that are very similar. We just kind of want to see what they look like. So, and what the differences will be. So for A and B, we see that by us having a negative without the parentheses there on the negative 5 here, that the difference in between A and B is that B is negative and A is not. For C, we now see that we have the parenthesis over the negative 5, so therefore that changes the nature of everything as well. And so for D, we have negatives everywhere, but not necessarily in parentheses. So we see that now that changes our answer to negative 25. And for E, we see that once we add the parentheses, it's the same result as we would have in D, but it is positive instead of negative. So now we're going to do our own here. So we know that 2 2/3 raised to the second power is just 2/3 times 2/3, okay, which will just be 4/9. If we do negative 2/3 raised to the second power, that's like a negative 2/3 times a negative 2/3, which would be a positive 4/9. But in this case, the negative is on the outside, so we look at it like this. Okay, more like a -1 being multiplied times that. So that would be a -1 times 4/9, which is a negative 4/9 in this case. For D, we see that 2/3 raised to the negative 2 power is the same as 1 over 2/3 raised to the positive 2 power. And of course, 2/3 squared is just 4/9. And of course, 1 over 4/9 is the reciprocal of 4/9, which is 9/4. We just flip the fraction. So for E, we see that the one thing that's different now is that we have a negative sign on the 2/3. So this would be 1 over negative 2/3 squared. But of course, negative 2/3 squared is just negative 2/3 times negative 2/3, which is a positive 4/9. So we see that we still end up having the same answer, which is 9 divided by 4. Okay? Because when we take the reciprocal. Now for F, we see that we have, this is going to be a -1 times 1 over 2/3 raised to the positive 2, which this is going to be a -1 times 1 over 4/9. And of course, the reciprocal of 4/9 is 9/4. And of course, 9/4 times a -1 is a -9 over 4. Okay? So now what we're going to do in this example is specifically use these two rules to be able to reduce or simplify our expressions here. Okay. So for the first one, we see that 3 raised to the 2 times 3 raised to the 4. Bases are the same, so we can add the exponents. For B, again, the bases are the same, so we can add the exponents whenever we're multiplying. So here, if the bases are the same, we can add the exponents. And here, plus a negative number is the same as subtraction. So we have B raised to the -5. For D, we see that we multiply numbers with numbers. So 3 times -4 gives us a -12. And of course, multiply exponentials, same base, we can add the exponents. So we get -12 y raised to the 7. So for E, when we do it, we could take -7 times -3. We can do that times B raised to the -7 plus -3 by adding the exponents since the bases are the same. So -7 times -3 is a positive 21. And of course, B raised to the -7 plus a -3 would be the same as B raised to the -10. And if we are asked to do this all in positive exponents, we know that this would just be 21 divided by 1 over B raised to the 10, which would just be 21 over B raised to the 10. For F, we see that we have Z to the 4th divided by Z, which is understood to be Z raised to the 1. And so bases are the same. We're dividing, so therefore we can subtract the exponents. We'll see we get z raised to the 3. Same deal here. We have w raised to the 18th minus, so subtract a negative 12. And of course, subtract a negative is the same as addition in this case. So we have w raised to the 30. For h, we see that when we are dividing these two exponentials, we separate the 4/12 along with the a raised to the negative 5th and a raised to the negative 2 powers. So for 4 divided by 12, we know that simplifies to 1/3. For a raised to the 5th, a raised to the negative 5th, or rather divided by a raised to the negative 2, we subtract the exponents, which gives us negative 5 plus 2, and it gives us a result of a raised to the negative 3 for the a part. So now we take this using this exponential rule here to rewrite a raised to the negative 3 as 1 over a raised to the positive 3. And then we just multiply these two things together to get this answer. So for I, we would take negative 3 divided by negative 21, all that times a raised to the negative 3 over a raised to the negative 4. We know that a negative divided by a negative is a positive, and 3 over 21 reduces to 1/7. Have a raised to the negative 3 minus a negative 4, which is addition, since subtracting negative is addition. And so this will be a raised to the 1, which is the same as 1/7 times a, or a raised to the 7. Sorry, a divided by 7. And now lastly, we have just 5 by itself here. Since we're multiplying, we're going to multiply y to the 2nd power times y to the negative 3 power, which will end up being y raised to the 2 minus 3 times z to the 1 plus negative 1. Handle these two here. Of course, this will be 5y raised to the negative 1 times z raised to the 0. And of course, 5 raised to the negative 1 will be 5 times 1 over y times 1. And if we multiply all that together, we get 5 divided by y. Okay, so to finish up here, now that we have these rules, we're going to go ahead and just work these out. So I'm going to work these out for you quickly so you can see how these end up looking. So negative 2 raised to the 4, we look at as negative 1 times 2 raised to the 4 plus 1/2 raised to the negative 1. So this is just 16. So we have a negative 16 plus 1/2 raised to the negative 1 is the same as the reciprocal of 1/2, which is just 2. And so negative 16 plus 2 is a negative 14. For b, we have 3 divided by 6 times x raised to the negative 6 minus a negative 5 times x raised to the 2 times y raised to the negative 1 minus negative 2. Of course, we know that we have addition there. We know that 3 divided by 6 is the same as 1/2. X raised to the negative 1 times x raised to the positive 2. And y raised to the 1. And of course, here we know that this could just be looked at as x raised to the negative 1 plus 2, which would just be 1/2 times x raised to the 1 times y raised to the 1, which would just be 1/2 xy. For example D, we'll have the following. 5 times 1 over 3 squared minus 2 times 5 to the 0 is just 1 times 3 raised to the 3 raised to the negative 1 is just 1/3. So we have 3, excuse me, that didn't work out too hot. So 3 squared is just 9. So if we put that over 1, that will be 5 over 9 minus 2 times 1 is 2. 2 times 1/3 is 2/3. And then, of course, from there, we need to find a common denominator. So least common denominator between 9 and 3 is 9. So we multiply numerator and denominator of the second term by 3. So we get 6 over 9. So our answer ends up being a negative 1/9 there. Okay. For F, we know that 2 raised to the 0 power is 1. 3 raised to the 0 power is 1. And x raised to the negative 2, if we rewrite that after adding 1 plus 1 is 2, is just 2 times 1 over x to the positive 2, which just ends up being 2 divided by x squared. Okay. And so for our last two examples, here I'm going to combine the numerator first here. So if we multiply a with a here, we're going to get a squared. Of course, the negative there with the 6 will give me a negative 6. And we'll have b raised to the negative 2. In the denominator, we have negative 2a squared, b raised to the negative 3. So we see here that a negative divided by a negative is a positive. I guess that's not agreeing with me today. And 6 divided by 2 is 3. So we'll just say 3 here. The a squareds reduce to 1. So we have 3 times 1 times b raised to the negative 2 over b raised to the negative 3. And so that will be 3 times b raised to the negative 2 minus a negative 3. And subtracting negative is the same as addition. So we have 3b raised to the negative 1, which is just 3b. And then our last example, anything raised to the 0 power is 1. So we just have 1 raised to the power of 5 plus 1 raised to the power of 6 minus 1. 1 raised to anything is just 1. So we end up just having 1 as our answer. And thus this concludes the video on exponential rule basics.